Module 1 taught you how to diagnose the problem. Now you decide what to do when the answer is matrix acidizing. Look at the numbers. 4 times improvement in productivity. That is not optimization. That is recovery. That happens when near-wellbore damage reduces permeability to a fraction of its original value. Remove the damage, and the well returns to its real capacity. Now look at the constraint. Below fracture pressure. That is not optional. Cross it, and you change the entire process. This lesson is simple. What matrix acidizing actually does, where it works, and when it should never be used. Wells lose performance because flow is restricted. The restriction is inside the formation, not the wellbore. That is the gap matrix acidizing solves. Matrix acidizing means one thing. You inject acid into the formation, below fracture pressure, to remove damage and restore flow. 3 conditions must exist. Acid must enter the rock, not stay in the wellbore. Pressure must stay below fracture pressure. The objective is removal, not creation of permeability. If you fracture the formation, you are no longer doing matrix acidizing. The mistake most engineers make. They assume pumping acid guarantees improvement. It does not. It only works if the acid reaches the damage and reacts correctly. This is a chain. If one step fails, the outcome fails. First, acid removes damage. It dissolves scale, fines, and drilling residue. Second, permeability increases. Blocked pore throats reopen. Third, flow improves. Resistance near the wellbore drops. Fourth, productivity increases. Same reservoir, higher rate. This is not theory. The entire benefit comes from restoring a small zone of rock. But this chain only works if acid contacts the damaged zone. If it goes somewhere else, nothing changes. Now connect it to numbers. In severe damage, permeability near the well can drop to 5% of its original value. That creates very high skin. The well can operate at a fraction of its capacity. Remove that damage, and productivity can increase multiple times. Same well. Same reservoir. Only the restriction changes. Now look at where this works. Sandstone, about 1 foot of penetration. Carbonate, up to 20 feet through wormholes. That is enough. Because the near-wellbore controls the whole system. You do not need to treat the entire reservoir. You only need to remove the choke. This is a decision gate. 3 conditions must all exist. First, the formation must have permeability. If the rock is tight, acid will not fix it. Second, damage must be restricting flow. You confirm this with skin. Third, you must not need a fracture. If the well requires a new flow path, acid will fail. Now look at the mistakes. Low permeability fracture, not acid. Wellbore blockage cleanout, not acid. This is where engineers lose money. They apply the wrong tool to the right problem. And nothing changes. This is where most designs fail. First, depth is limited. In sandstone, acid reacts and is spent within about 1 foot. In carbonates, maybe 20 feet. Beyond that, it does nothing. Second, placement. Acid flows to high permeability zones, not to damaged zones. Without control, most of the acid misses the target. Third, mineralogy. Wrong formulation creates precipitation. You can make the damage worse. Fourth, secondary damage. Iron, reaction products, poor cleanup, all create new blockage. So understand this. Matrix acidizing is not easy chemistry. It is controlled engineering. Matrix acidizing removes near-wellbore damage. That is its only objective. Permeability increases because blockage is removed, not created. Flow improves because resistance is reduced. Production increases because the flow equation changes. But everything depends on control. Stay below fracture pressure. Use the correct formulation. Control placement. If the acid does not reach the damaged zone, the treatment fails. If the design is wrong, you can make the well worse. So take this as the rule. You are not pumping acid. You are removing a restriction. This slide is your checklist. Matrix acidizing removes damage, reduces skin, and restores flow. It only works in the near wellbore. It requires permeability, damage, and no need for fracture. Its limits are depth, placement, and chemistry control. Get these right, and production improves. Miss them, and the job fails.